Hi, I'm Evan. I'm part of the technical team here at Zymbit, and welcome to part 2 of the Bootware tutorial. If you have not watched part 1, where we go over how to create an image, the link to the video is down below. In this part, we'll be going over how to actually deploy an image to a device. One important point to mention that is if you have a fleet of devices, every device in that fleet needs to have a starter image that has Bootware installed and has the public key that associates it with the source private key in order to accept updates and verify them. Now that the ZBCLI is done creating our ZI image, we now have 3 different files that have been created at the specified mount point where you wanted to save your files. The first is the actual image file. The second is the public key, and the third is the private key that's used to sign this image. Now that we actually have an image that we can now update systems with, the next thing we want to do is actually configure Bootware to accept that update and how it wants to accept and apply that update. Copy the public key that was created with the public-private key pair somewhere onto the Raspberry Pi so that it can then use that to accept and verify the update. I'm going to do that here and copy it to my home directory. And now I have my public key ready to verify the update that we're going to apply later. Now we're actually ready to configure Bootware and decide how we want to apply this update and partition our device. To do that, we're going to run our ZBCLI update config. Now it's important to mention that this step will give you a bunch of different options to configure how Bootware operates. If you have a fleet of devices, each device in that fleet has to have these configurations already preset. That means all the different endpoint options. So if you're using Wi-Fi as your wireless endpoint to pull an image, it has to have the configuration already set on that device with the Wi-Fi credentials and the endpoint to properly pull and apply the update. With that being said, let's start walking through the different configuration options. The very first is the partition layout. What Bootware does is that it'll completely rewrite your file system the very first time you do a Bootware update, in this case on the source device. Because I've never run Bootware before, the entire partition takes up the entire device space. This is not the case if you've already run Bootware before and pre-configured how it operates. That's what you see as these 3 options here. The very first time Bootware runs, it'll completely wipe the disk and then repartition your device with the configuration that you select here in the Bootware partition layout. The first one that you see is what we recommend is an A-B layout. So this creates an A partition, a B partition, and then a small shared data partition that you can specify the size of in a later step. The next option is just to do a single A partition that takes up half the disk. The third option is to have a full disk, which is similar to what you're starting with now. For this tutorial, I'm going to select A-B partition layout. The next configuration option is going to be the update policy. So this tells Bootware where you want to apply the update. Depending on your partition layout, this might be different. If you have an A-B layout like we've previously selected, you can decide whether you want to apply the update to your currently active partition or your backup partition, or apply it to both, in which case you'll have the same update image on both partitions. For this tutorial, I'm going to select backup, so what we're going to have is an A partition running the current image we have, and a B partition running the updated image. In this case, it happens to be the same image because we used image the live system when we created our first ZI image. This might be different on fleet devices, and it'll apply the update based on the policy you preset during the configuration of that individual fleet device. So if your fleet device has an A-B partition layout and you select the update policy to only update the backup partition, this update will be applied to the backup partition, and therefore your fleet device will have an active partition, which is running its current software, and this update as its backup partition. So now I'll select only updating the backup partition for this specific device. Now we have the option to configure how big we want our shared data partition. So this is data that can be accessed by either A or B if that's the configuration you have. It's a shared data partition that can be accessed universally. The default is 512, which for my scenario here is perfectly fine. These next steps are required if you're using a wireless URL endpoint for your Bootware updates. Bootware has the capability to use HTTPS URLs as an endpoint, so you can host things on a server and have them be pulled down by Bootware and have the updates be applied. This is the step where you either select the mount device, in this case, where we've stored our update, or this could also be an HTTPS URL. In this tutorial, I'm saving my image onto the USB device, so I'm going to select dev SDA1. Once this device is selected, you can see that it went into dev SDA1 and found the update image name, my image, and saved that as the image it's going to update with in future steps. If this was an HTTPS URL, it would go and check the URL and make sure that the image is actually there. If you have multiple images, it'll give you a menu from which you can select which update you want to apply. That is all the necessary configuration steps needed to run a bootware update. However, if you're using a fleet of devices that are using remote or wireless capabilities, it's very important that you go through and configure the SSID and password for which those devices need to connect to in order to pull a remote update. This needs to be done before you actually run a bootware update in the configuration of that fleet device. For the rest of the settings, please refer to the Zymbit documentation for more information. It's also very important to note that you must save and exit this update configuration. If you just Control-C out, the settings will not be applied and your bootware update will fail. So we'll go down and select Save and Exit. So what have we done up until this point? We started with a Zymbit HSM, a Raspberry Pi. The Zymbit HSM driver is installed on that Raspberry Pi and running, which is necessary before you run any bootware updates. We then installed the bootware software packages on top of this driver package. Then we created an update image from this live running system from which we're going to update our devices. And then we updated our configuration for how bootware is going to download and apply that update. The last step is to actually go ahead and update the device. All you have to run is sudo zbcli update. Once you run this command, it's going to make sure that all your configuration settings are correct. And if so, you're welcome to go ahead and run the update. If not, you have the option to go back and adjust any configuration settings that aren't correct. So in my case, this all looks good to me. So I'm going to select yes and have the update run. Now once this happens, your device is going to reboot. It can be helpful to run a console and look at the output of the Raspberry Pi device. During this process, you'll also see a bootware splash screen that will give you a progress bar indicating how far along in the process it is. Before I can run the update, I have to provide the public key to verify the update. Or this key was moved onto the Raspberry Pi in an earlier step when I copied it from my USB stick onto the local directory. I can just search, it'll autocomplete here. So my image public key.pem. So that's the key I'm going to use to verify the integrity of the update. Now it's running the bootware update. During this process, it's going to show you which files have been created or modified to run the actual bootware update. Now that everything is scheduled for a reboot, we can select manually to update the device, which reboots. And this is when you'd want to look at the console output of your Raspberry Pi to get more information. This will also include a bootware splash screen with a progress bar indicating how far along in the process it is. All right, it looks like our bootware update has finished. It took approximately 16 minutes for this to happen. So let's log back in and check out what happened. The first thing we'll look at is our partition layout. As you can see, this is different from before. We now have our encrypted partitions. Right there you see crypt FSA and crypt FS data. Now where's crypt FSB? Well, that partition is not mounted because partition A does not have access to partition B. So it's actually in MMC block P3. Even if partition A wanted to access and mount partition B, it's not able to do that because it does not have the proper keys access partition B. This is done as a design choice and intentionally in ZBoot to protect user security and isolate between different partitions. So right now we're in partition A, but let's go and boot into partition B. To do that, I'm going to run sudo zbcli rollback swap. Now what's going to happen here is the Pi is going to reboot and go into Zymbit Secure Enclave, zboot, which is then going to boot into the root partition of B. Let's go ahead and do it. It's going to ask you to confirm that you're going to boot into the non-active root partition. We're going to say yes. Now it's rebooting, and when it comes back up, we'll be booted into partition B. All right, our Pi is now rebooted, so let's go in and take a look what's happened. So if we take a look at the LS block, you'll now see crypt FSB, which is mounted from MMC block P3. You also see the crypt FS data, but you will not see the crypt FSA because just as before, partition B does not have the keys to access or mount partition A. On the destination device, we now have full at-rest encryption, secure boot support, A/B updates with automatic fallback and recovery, along with all the security services such as hardware key encryption APIs, PKCS storage, and physical security services. You can find all the links below. Thanks for watching.